Yes, Ms. Grange.
Yes, good afternoon, Mr. Chairman. Could we please call Professor Torero?
Thank you. Good afternoon again, Professor Torero. Welcome back. I think it's right that we ask you to affirm again. I'm sorry, but the words are there on the screen. Would you read them out, please?
Yes. I do solemnly, sincerely, and truly declare and affirm that the evidence I shall give shall be the truth, the whole truth, and nothing but the truth.
Thank you very much. Please sit down. Make yourself comfortable there. Yes, when you're ready, Ms. Grange.
Yes, thank you. Yes, good afternoon, Professor Torero. I'm going to be asking you the questions today and into tomorrow. Please, if you don't understand any of my questions, just ask me to repeat it, or I'll put the point in a different way. Please try and keep your voice up, and also try not to speak too fast, because the transcriber's taking a live note of your evidence.
Okay.
So you gave us a presentation last Thursday on the 9th of June, based on a report that you'd provided. If we could go to that, that's JTOR 706. So this is your Phase 2 Grenfell Tower Inquiry Adequacy of the Current Testing Regime report, dated the 4th of January 2022. And I asked you to confirm the truthfulness and the opinions in that report last week. There's a further report that you provided to the inquiry that you will be asked questions about at the end of your evidence tomorrow. Mr. Kinney is going to ask you those questions. And I just want to bring that up. That's JTO 705. Yes, so there we have an earlier report that you wrote. It's dated the 15th of August 2021. It's Phase 2 Grenfell Tower, London Fire Brigade and complex building fires. Further considerations on the presumption of technical competency. And those questions tomorrow will be about the water supply to the tower. Okay. Now, just in terms of this report, is that your signature there that we see on the front?
Yes.
Have you read that report recently?
Yes.
Have you provided that report in the same way that you would have provided the report to an English court?
Yes.
And can you confirm that the facts and matters set out in the report are true to the best of your knowledge and belief?
Yes, they are.
And can you confirm that the opinions you provide in that report are honestly held professional opinions?
Yes, they are.
Thank you. Now, you've given evidence before, including about your background and your experience and expertise, but I just want to recap over some of that, because some of that's going to be quite pertinent to some of the topics we're going to cover today. So if we go to section 1.2 of your testing report, this is on page 4 of JTOR 706. So here we've got a précis of your expertise in this section of your report. And I just want to update and flesh that out. So it's right, isn't it, that you're currently Professor of Civil Engineering and Head of Department of Civil, Environmental and Geomatic Engineering at the University College London. Is that correct?
That's correct.
And before that, between 2017 and 2019, you were at the University of Maryland in the USA. Is that right? And at that university, did you hold the John L. Bryan Chair at the Department of Fire Protection Engineering?
Yes, I did.
And were you also the director of the Centre for Disaster Resilience?
Yes, I was.
And then earlier to that, between 2012 and 2017, did you hold the role of Professor of Civil Engineering and Head of the School of Civil Engineering at the University of Queensland in Australia?
Yes, I did.
And before that, you held leadership positions, including at the École Polytechnique Fédérale in Lausanne, Switzerland. Is that right?
Yes, I did.
In 2012. And also a number of positions between 2004 and 2011 at the University of Edinburgh.
Yes, I did.
Including you were the BRE Trust Royal Academy Engineer Chair in Fire Safety Engineering between 2004 and 2011.
Yes.
Thank you. Now, as to your formal qualifications, you initially trained as a mechanical engineer in Peru, is that right?
Yes.
And you were awarded a Master of Science and a PhD by the University of California, Berkeley, in mechanical engineering with a speciality in fire safety.
Yes.
And you are a chartered engineer through the Engineering Council division of the Institution of Fire Engineers in the UK.
Yes.
And you're also a registered professional engineer in Queensland, Australia.
Yes.
A full member of the Society of Fire Protection Engineers in the US.
Yes.
And you were a fellow of a number of bodies, including the Royal Academy of Engineering and a fellow of the Royal Society of Edinburgh. Is that
Yes,
correct?
that's correct.
And we can see you've also been awarded a number of accolades and prizes, as you go on to explain in paragraph 1.2.3 at the bottom of that page. Just to pick up on a couple of these, there are a number of prizes. In 2008, you were awarded the Arthur B. Gies Medal by the Society of Fire Protection Engineers in the USA. Is that correct?
That's correct.
And in 2011, you were awarded the David Rasbach Medal for the Institution of Fire Engineers in recognition for eminent achievement in the education, engineering and science of fire safety.
Yes, I did.
And you're also the author of more than 500 technical documents in all aspects of fire safety, of which more than 200 are peer-reviewed scientific journal publications.
Yes, that's correct.
And is it right to say that you've been the editor for a number of scientific journals as well?
Yes.
And in 2010 to 2016, were you the editor-in-chief of the Fire Safety Journal?
Yes, I was.
And is that the most respected journal in the field of fire safety internationally?
Yes.
And you've also been involved in a number of high-profile fire investigations, including an independent investigation into the World Trade Center building collapses. Is that correct?
That's correct.
If we look at your report at page 6, I want to go to paragraph 1.2.7. There you also set out your extensive experience in the education and training of fire engineers, fire investigators and the fire service. Is that right?
That's correct.
So you tell us that you've been involved in that for more than 20 years and you've developed training programs on fire investigation, etc., in a number of different jurisdictions. Is that correct?
That's correct.
And that includes, if we look down the paragraph, about 6 lines up from the end, you've designed fire engineering, fire safety courses at the University of Queensland. Is that correct?
Yes, that's correct.
Yes, and I'm going to come back to that. Now, moving on to some substantive topics, I want to start today with some questions about how other jurisdictions have addressed the risks posed by external facade systems. Because we've heard a lot about the domestic regime, including over the last 2 days with Professor Bisby, but I want to try and contextualise the UK position with what we see internationally, and obviously you're well placed, given your expertise, particularly in the US and Australia, to provide that. So that's where we're going to go first. And then I'm going to come back to some more detailed questions about the UK's testing regime, or the regime in England and Wales, before addressing some of the conclusions that you've drawn in your report. So that's the broad structure I'm going to follow.
Okay.
Now, you set out some analysis of the response of other jurisdictions to the fire safety design of external walls in your report at Annex A3. That begins at page 210 of this report. So if we just go to that to orientate ourselves. So there, under the heading Changes in Regulation and Practice, you begin a section which looks more broadly at other jurisdictions and their responses. Now, to start with, you tell us that some countries had banned the use of combustible materials in external facades prior to the Grenfell Tower fire. Is that right?
Yes. I mean, it is not that they have banned them, but they were never allowed.
Yes.
And so a good example is Hong Kong, for example, where it has never been allowed in high-rise buildings to have combustible materials.
Yes. And you also say that in some cases, regulations were strengthened after the Grenfell fire, which effectively make it impossible to use combustible materials. Is that correct?
Yes, that's correct.
And you give the example of Hong Kong. You also give the example of France, Germany and China, of states that have adopted a no-tolerance approach to combustible materials. Is that correct?
Yes, that's correct.
Yes. And then later in your evidence, just to be clear, we'll come back to your views on the efficacy of banning materials. I will return to that topic later. But you've then, in your report, you've provided more detail on 3 main jurisdictions, the US, the UAE or Dubai in particular, and Australia. Is that correct?
That's correct.
And is that because those are the 3 most interesting other jurisdictions to look at? in terms of where this jurisdiction might go in the future?
Yes, they cover a range of different approaches. That it was, I think, important to highlight those three because they cover a full range of approaches.
Yes. So let's start first with the United States and their response to this problem. Now, is it right that the United States doesn't have a unified regulation as to fire safety design, and it is left to each individual state?
Yes, in principle, each individual state will have its own regulations. They generally all coincide in many of the key aspects, but at the end, the regulatory framework is a state regulatory framework.
Yes. And you go on to explain that nonetheless, the National Fire Protection Association, known as the NFPA, is a body which exercises huge influence in the way that fire safety is implemented across the US. Is that correct?
That is correct.
And you tell us that this organisation has extraordinary confidence in their current approach to external facade fire typology. Now, can you just help us with what you mean by that? When you say that organisation's got extraordinary confidence in their current approach to this problem, what do you mean by that?
Yeah, as opposed to the United Kingdom, where you have the prevalence of functional requirements in the United States, you do have the option for performance-based design, but the primary means of delivering fire safety is through a very strong and strict prescriptive regime. And the National Fire Protection Association, like the International Building Code or ICC, they are effectively prescriptive codes with an option of minor departures. Now, given that the codes are very, very prescriptive and that the rules are set as rules, the process by which they achieve the objectives is deemed to be an unalterable and unchangeable process, and which is generally confirmed by historical data that NFPA, for example, collects on a regular basis, that enables them to affirm that they have not really had any major incidents, and therefore talk with great confidence that their set of rules is adequate and sufficient to try to manage this particular problem.
Yes, thank you. Now, the NFPA have helpfully provided a statement for the inquiry about their experiences in the USA, and that can be found, if we just bring that up, at USA 601. So there we have a submission that the inquiry received from the National Fire Protection Association to the inquiry about the system of regulation in the US. Now, the first point that you note in your report about this submission is the heavy reliance placed on a particular test, and that's called the NFPA 285 test. Is that right?
Yes, that's correct.
And if we go to page 6 of this submission, I want to look at section 3. So under section 3, the second paragraph down, it says this: as mentioned above, the combustibility of facade systems in the US is controlled by facade system assemblies with combustible components passing the rigorous fire test procedures of NFPA 285. This test protocol is similar to BS 8414 and is mandated for use predominantly on high-rise buildings where a combustible component may make up part of the building's exterior wall assembly. And then they go on, having a rigorous test is not enough to control the fire risk. It's important to ensure that what is specified as well as installed is the same as what's tested. And it goes on. Now, just to be clear, so the NFPA 285, that's a large-scale fire test, isn't it?
Yes, it's a large-scale fire test, very similar, as they indicate, to BS 8414.
Yes, so you agree with what's said here, that it's similar in design to an 8414
yes.
test. And just to be clear, later in your evidence, we will come back to some of the detailed criticisms you make of the 8414 test, but we'll keep with this for the moment. Now, if we could go to page 229 of your report, so back to JTOR 706 at 229. I just want to read at what you say from paragraph B127 onwards. You say this: broadly, the context in which an NFPA 285 test is required by the IBC or NFPA 5000 is when the project wishes to include combustible components in a wall assembly that's otherwise required by code to be non-combustible. It can be inferred from this that a pass in the test is deemed to be equal to non-combustible behaviour. In actuality, a pass in that test equates to a limited amount of fire spread over a period of 30 minutes, and therefore this equivalency has the same weaknesses described above in relation to the failure criteria for BS 8414. And you go on in the next paragraph, B128. Having distilled the project characteristics and placed the design in a classification system, the context of the end-use application of the external wall ensemble is lost and is entirely removed from the pass-fail classification system of the test. The aforementioned imprecise equivalency, limited fire spread equals non-combustible, is made independently of the end-use scenario and does not consider the nuanced performance required of individual fire safety strategies through the building classification. And then I just want to read one more paragraph here, B129. It is therefore possible that an external wall system that meets the pass criteria of NFPA 285 may be appropriate for some end-use scenarios, but not others. While in the UK system, the onus is openly placed on the designer and engineer to interpret the test results and observations in the context of the end-use scenario. As stated previously, in the US system, no such assessment is mandated. So I think effectively what you're saying is the test provides an answer. It doesn't expect interpretation, and either that answer is you can use it or you can't. Is that right?
Yes, and I think that is contextualized by the structure of NFPA codes or IBC or ICC codes. So what you have in the United States is that you're going to have a set of rules, and therefore there is no variability in how the fire safety problem will be resolved. So you start by classifying the building, and if you classify the building as a residential building, there is only one solution to the problem. And therefore, because there is only one solution to the problem, if you introduce combustible materials, is taken by NFPA 5000, which is a performance-based design element of the code. And therefore, they require that test as a substitute that basically is a final piece of the puzzle that gets fit in an otherwise completely rigid solution to the problem.
Yes, thank you. And if we go over the page and look at B138, you say this, you say NFPA 285 was conceived as an acceptance test and therefore does not require interpretation by a competent professional. This is compatible with the US regulatory framework, but is inconsistent with the approach towards fire regulation adopted currently in the UK. So just to be clear, I think you've just explained why that's compatible with the US framework.
Exactly.
But just help us, why would that be so inconsistent with the approach towards fire regulation that we have here?
Because when you have the functional requirements, you're going to have multiple solutions that in principle could be deemed as meeting the functional requirements, and it will be the designer or any of the professionals in the process that will determine what is the path to compliance. Now, if you have a complicated situation that has multiple variables and you are incorporating that into a system that allows multiple solutions, the possibility of making a mistake is enormous. But if you have a system that is completely rigid, that only has one solution, you could actually work this into that solution so that it actually meets the requirement of that specific solution, because it's the only one that you're going to have.
Yes, I understand. And then you go on, B139. Otherwise, NFPA has very similar limitations to those already described for BS 8414. It does not provide any additional information that cannot be obtained from BS 8414, and the testing protocols used cannot provide further data in support of building design. So effectively, you would say it's a poor test in terms of providing you with a range of information that you might need to make a holistic assessment of external wall performance. Is that fair?
Yeah, absolutely. But nevertheless, as we discussed when I gave my presentation, there is a certain tail that gets cut by the test. Now, that tail, because the provisions within NFPA, for example, do not include a stay-put strategy. Many times a high-rise building will be required to have sprinklers. You have similar levels of compartmentation. You might end up having the need for 2 stairs. plus pressurization and all sorts of other things that are required by the North American code, cutting the tail might end up being a lot more effective than when you just simply cut the tail and nevertheless give complete freedom, to design multiple solutions that might not have all those redundancies or robustness that the prescribed NFPA solution has.
Yes, thank you. That's helpful. And I was going to come on to that. So is it right that in the US, they don't have a presumption of stay put that underpins all this?
No, the system in the United States is effectively a system that will require some form of evacuation at all levels.
And when you mean some form of equation, do you mean that they adopt a phased evacuation strategy?
It could be phased evacuation, it could be total evacuation. There are sort of different options that you might have depending on the type of building that you have. And but you will always proceed to evacuate people at a certain rate.
Yes. And has stay put ever been an underlying assumption in the US system, as far as you know?
Not in the way in which we see it in the UK. You can argue that there's an element of stay put in the sense that some people will wait for others to evacuate, so you have the staged evacuation process that can be a very, very long process. So for some people, yes, there is an element of stay put, but essentially you have a rate of egress that is introduced into the code.
Yes, and I think what you're saying is the provisions, other provisions in the building, for example, provisions for sprinklers, all support that central fire safety strategy. Is that correct?
Absolutely, yeah.
Yeah. And would you describe the NFPA test, 285 test, as a rigorous fire test procedure? That's how it's described in the submission to the inquiry. Would you describe it as rigorous?
No.
Can you explain why?
Yes, I mean, I think that the NFPA test, as I indicated in my report, suffers from fundamentally the same problems that BS 8414 has, which is intended to be a scenario test, where as a start, the scenario is not well characterized. Then the measurements that you have are very minimal, and therefore the information that you can extract is very limited. And the test follows a protocol that effectively addresses one set of conditions and leaves an enormous amount of variability when it comes to the interaction between that set of conditions and the facade system that you're trying to assess. So in that sense, it is very much an equivalent, to BS 8414. It's just simply slightly different.
Yeah. And in fact, I think elsewhere in your report, you refer to a study conducted by FM Global, which compared the NFPA 285 with another standard, the ANSI, the American National Standards Institute, the FM 4880 standard. And you say that the authors of that FM Global study concluded that materials can pass the NFPA 285 test, but can fail that other test. Is that correct?
Yes, the FM Global standard recognizes that the range of heat fluxes that you can have from a fire that is being projected in a window can reach much higher levels than what the NFPA 285 test can produce. And therefore, they created a scheme by which those higher heat fluxes could be reproduced. And by doing so, they found many materials that would have passed NFPA 285, but were not deemed satisfactory according to the FM Global test.
Yes. So that test, that ANSI FM 4880 test, creates thermal conditions that are more relevant to an external fire scenario. Is that correct?
Yes, that's what they were attempting, to cover a broader range of conditions than the very narrow range that NFPA 285 covers. And by creating a broader range, they go to a much higher heat insult for the facade system.
Yes. And so I think, in essence, what you're telling us is that, in your opinion, the NFPA 285 test is not the best way to be assessing external facade fire performance. Is that correct?
Yes, as we have said, as I've said numerous times, a test is a test. A test provides you with information, but as a criteria that serves for acceptance, the only thing it does is it cuts a tail. And it doesn't really provide you with a robust methodology for acceptance.
Yeah, and when you use the phrase cuts a tail, I think what you mean is it excludes the worst performing systems.
Yes.
But you're then left with systems which
could be potentially very bad, but nevertheless are capable of passing the test.
Yes.
So the only thing that you can say at the end when you apply those tests is that if it fails the test, it's absolutely terrible.
Yes. And I think what you said earlier was that there were other elements of the US code which might ensure higher standards of fire safety, like the use of sprinklers, phased evacuation, etc. 2 staircases, is that right? Is that another presumption?
So 2 staircases is very common in the United States. It's part of most building codes, and so yes. I mean, what the North American system has, as I said before, it has a lot of provisions. And it's a very extensive code, but also it has a very narrow range of applications, so there's no variability on the solution. So you know exactly what the solution is going to be, and that solution generally incorporates a very large number of provisions that you will normally not see in the United Kingdom. Whether those provisions are necessarily useful or appropriate, that's a different story. But the reality is that they have a much greater number of provisions.
Yes, thank you. That's helpful. Has there been any criticism of the regime in the US in terms of how rigorous it is, how inflexible it is? Is it the subject of criticism?
I think prescriptive requirements of that nature are always a subject of criticism. But the approach that people have taken in North America is a constant revision of the code that is driven by practice. You know, whether you're a manufacturer, you're a fire engineer, or you are a building developer, they have an approach that they call the consensus approach, by which NFPA committees meet on a regular basis, and they are making the code evolve in such a way that they enable the use of new technologies, or they improve things on a regular basis. So their approach has not been to give freedom to the practice, but has actually been of incorporating the practice in the constant redevelopment of the code. And by doing so, they're giving a voice to every stakeholder to participate in the changes of the code. So it's really a very, very different approach. But there is always a natural criticism to the rigidity of a prescriptive code, and this is the reason why they incorporated NFPA 5000, which effectively gives you an opening, towards delivering a performance-based design that allows a competent professional to come up with an alternative solutions. Now, the reality is that what you will get in the United States is a 99.99% prescriptive solution with maybe a couple of very minor variants. That's what NFPA tends to offer.
Yes. And how successful has the NFPA been in managing to innovate the code to keep pace with, say, modern construction methods?
I think they have been... It really depends on who the judge is, because the reality is, because it's developed a culture of participation. Most of the stakeholders will be involved in areas of the code that pertain their own business. Now, that is good and bad, and because obviously certain participants are going to be constantly lobbying for changes in the code that benefit them. But I think in essence, because the culture has been one of participation, in the United States there's an enormous confidence on the fact that the code actually delivers the necessary safety while taking into account cost, taking into account the evolution of technology and so forth. And as you saw from the submission from NFPA, point number 1 was the statistics. It is constantly validated by improved statistics of life loss and property loss. So they're constantly validating that approach by collecting the statistics and showing how improvements are being introduced.
Yes, I see. So would you describe the code as a very conservative code, even though it evolves?
Yes, I would.
Yes, and that's just accepted as the way it is in the US, that they have this quite conservative approach to their prescriptive rules and regulations.
Yes, I mean, obviously coming from a European perspective or an Australian perspective, I will say it is very conservative. I mean, clearly they will not think of it as a conservative code, because it is embedded in the culture. It is the culture that the evolution of fire safety has had for 100 years in the United States.
And can you, this is probably an impossible question to ask, and feel free not to answer it, but can you pinpoint what it is that's led to that type of culture there in North America, and perhaps a different culture that we see, for example, here, in terms of margins of safety and conservativeness in the way that rules and regulations are drafted? Yeah,
I mean, I think this is something that obviously it is to some extent a speculation, but the reality is that there's a number of things that characterize, for example, the European market that were not the case in the United States. And for example, in Europe, there's been always a need for some higher level of freedom because of the existing stock of buildings. So there's a lot of historical buildings. The cities have evolved, from a very significant existing body of buildings, and therefore a lot of these very draconian solutions, like putting sprinklers everywhere, were not possible within the context of the building stock in Europe, and therefore there was always a need to try to be different. Then, of course, in the post-war years, there was an enormous amount of reconstruction that had to be done, and it had to be done very fast, and therefore having sort of expensive or rigid solutions, was probably not acceptable or even viable. So there's a number of reasons that I think have led Europe to evolve in a different way, and I think in many ways, because the United Kingdom used to be the bastion of knowledge in fire safety, there was a sense of confidence that also allowed a lot of freedom, and because there was a perception that we really understood the problem quite well. And so I say it's a number of variables, but I think in general they're more contextual than anything.
Yes, no, that's very helpful. Thank you. If we return to the NFPA submission to the inquiry, I just want to pick up where we left off. This is at USA 601, page 6, section 3. Yes, so we were reading the second paragraph under section 3, and I want to pick it up 6 lines down now. And it says this: having a rigorous test is not enough to control the fire risk. It is important to ensure that what is specified as well as installed is the same as what was tested. This can be one of the weakest points in fire safety, as it requires a high skill level of designers, installers and inspectors. Especially for complex exterior wall systems, it is often minor details that can make a big difference in fire performance, making it especially important to be vigilant through all steps of the construction, installation and inspection process. Now, can we take it from this that the US system does recognise the need for the tested system to be consistent with that which is specified and installed?
Yes, and it goes actually beyond, in the sense that in the United States, most of the trades that are involved in the process, including the profession of fire protection engineering, as they call it, they all require very, very rigid and specific certifications. So everybody in the process is certified. So from the authority having jurisdiction to the installer, they will have some sort of accreditation that enables them to do the job, because they recognize that given that they have a very rigid set of solutions, that those solutions need to be implemented in a very strict manner.
Yes. So is this right, that it's recognised that somebody's got to exercise some judgment and expertise to determine whether the results of that test are going to apply to the facade or the building in question?
No, it's not the results of the test. It is the whole implementation of the different provisions of the code. So a sprinkler installer, for example, has to be certified.
Yeah.
An individual who installs fireproofing or cavity barriers will have to have a certification, and those are required for them to be able to exercise the activity. And the same way, the fire protection engineer is a professional engineer who has to be certified in every state. Now, the people who conduct the test, the laboratory, again, is certified. And therefore, the certificate that the laboratory produces is a certificate from an institution that is recognized and generally regularly monitored, to have the skills and competencies to deliver the test appropriately.
I see. So I think what you're saying is at all stages of the process, everybody has to have achieved certain competency standards.
Yes.
And be certified as such.
Yes.
Yeah. And you make the point, relying on the NFPA submission, that in the US, it's also important that the enforcement professionals have those skills and that expertise. Is that right?
Yes, so there will be what the North Americans will call the authority having jurisdiction, and the authority having jurisdiction will have an equivalent certification to the engineering designer, for example.
So does that mean that they have to understand these external wall performance matters, as well as the fire engineer who's signed it off for use on a building?
Well, this is what is very interesting about the North American system, is that because you operate in a very prescriptive environment, the professional certification is very much related to your capacity of interpreting the code. So in many ways, if you are a fire protection engineer, for example, and you have a professional engineering accreditation, you will have some fundamental knowledge about fire safety, but most of the information that you are required to have, and you're required to take an exam and so forth, it relates to your capacity to understand and apply correctly the code,
Yeah.
which is pretty much the hallmark of a prescriptive system.
Yes, I see. So the expertise comes in the knowledge and understanding of the code, as opposed to the knowledge and understanding of the principles and the physics behind some of what's in the code. Is that fair?
Exactly, which basically means that you have reduced the onus on the professional, because half of the solution has already been resolved by the code, and your job is to be able to interpret it appropriately. As opposed to having to create the whole solution on your own, which requires a professional of a much, much higher level of competency. And a very different professional in mindset also.
Yes, I see. Yes, that's helpful. And then if we look at the bottom paragraph, I think this is going to reinforce some of the points you've been making. It states there, in the majority of cases and jurisdictions, those involved in the design, construction and inspection processes are typically required to carry some form of certification, licensing or similar credential that shows that they have achieved some level of competency in the area in which they work. Individual jurisdictions are typically charged with determining the level of accreditation or certification required for those involved in the design, construction, enforcement processes. Construction of a high-rise building would require the services of a registered design professional, an RDP. Multiple RDPs are likely to be on the design team, including and then over the page, including a licensed architect and licensed engineers, including in the disciplines of structural, fire protection and electrical, amongst others. In the US, the primary engineering credential to be attained is the professional engineer license. So that's the accreditation of all of those involved in the system. Yeah?
Exactly, and the ultimate level, the highest level, is a professional engineer, and each state will have to accredit you. So if I wanted to exercise in California, I will have to have a state of California professional engineering license, and if I want to exercise in New York, I will have to get one from the state of New York.
Yes. And in your opinion, how successful have those accreditation and certification requirements been in ensuring that there's the level of competency needed in the way you've just described it, so as to interpret the code and the requirements of the code?
I think they're very successful.
Yeah. Now, if we go back to the NFPA submission, again, at page 7, second paragraph down, it says, as can be seen from above, the US are faced with many of the same challenges as the UK when it comes to fire safety of high-rise buildings. Both countries have responded to the challenge through regulatory requirements, including use of facade fire testing. Some of the biggest differences may be found in the enforcement of the requirements. So is that a fair distinction that you would draw between the system here and the system there?
Yes, because effectively, the moment that you have a combustible material in your system, you have no choice. You have to conduct a test.
Thank you. Now, I now want to turn to Dubai in particular. Now, the panel has heard on several occasions about cladding fires in tower blocks in Dubai and elsewhere in the UAE. And Dubai Civil Defence has prepared a submission to the inquiry to assist the panel. If we could just go to that, that's at DCD 701. And this submission came in the form of a witness statement from an individual called Mr. Terence Ronald Johnson, and he's a Dubai Civil Defence officer. And this statement, you can take it from me, is dated the 1st of May 2020. So it's dated from then. You can see that actually on page 8, if we wish to. Now, just tracing back and thinking about the UAE more broadly for a moment, is it right that before 2011 there were no explicit requirements for the fire performance of facade systems in the UAE regulations?
That's correct.
But is it right that in 2011 there came to be something called the UAE Fire and Life Safety Code of Practice? Is that right?
Yes, that's correct.
And is it right that, but even then in 2011, that had no explicit limitations on external wall assemblies and no explicit reaction to fire requirements for buildings separated by more than 3 metres?
That is correct.
Then, is this right? After 2012, the Fire and Life Safety Code of Practice adopted some standards for external fire performance of walls, such as, in certain circumstances, Euroclass A1 and the NFPA 285 large-scale fire test. Is that your understanding?
That is correct.
So from 2012, they begin to introduce standards into their code by reference to tests, not domestic tests in the UAE, but tests from the US or Europe. Is that correct?
That's correct, yeah.
And is it right that part of Dubai's approach at this time, around 2013, was to ban non-fire rated assemblies for mid-rise and high-rise buildings?
Yes, that's correct.
Then in 2018, the UAE produced an updated UAE Fire and Life Safety Code of Practice. Is that right?
That is correct, yeah.
And do you understand that that 2018 code was in direct response to the Grenfell Tower fire?
Yes, it was in many ways because it's the first time that you have a set of rules that are truly enforceable.
Right, so prior to that, it was all optional, was it?
Mostly, yes.
I see, yeah. And we can take it from this submission, this Dubai Civil Defence submission, that was accompanied by a 10-point plan. And we can go to the list of those points in this submission. If we go to page 5, so there we can see they say, just above the bullet points, so a 10-point action plan to tackle facade fires, whilst we worked on a more permanent solution in the release of the 2018 code. And then the 10-point plan was as follows. And if we just read the first 3 points, it was that the core of the facade material shall be tested in naked flame form. So I think they're saying you have got to do tests on the core of any composite panel. Is that right?
Yes, that's correct.
Facade panel as a product must be tested, and then facade system as well as assembly shall be tested or listed as per test requirements of the code. Is that right?
That's correct.
So they're introducing certain prescriptive testing requirements.
Yes.
At that point. And then if we go, I don't want to go through all of these bullets, but if we go down 4 bullets and pick it up with consultants, 3 bullets from the end, it says consultants shall have competent and qualified facade specialists in-house or shall hire civil defence house of expertise who have experience and expertise in facade consultancy for facade design, system selection and supervision of facade contractor. Then the next bullet, facade contractor shall be approved by civil defence with valid civil defence licence. And then facade installation shall be inspected throughout installation process and certified by consultant or civil defence approved house of expertise. Do you see that?
Yes.
And you make the point in your report that, thinking back to the first 3 bullet points, the tests that are referred to there are very similar to those that are used in the UK and the US. Is that right?
That's correct.
But is it right that what's different is that certification of products requires both tests and adjudication by a group called the House of Expertise? Is that right?
That is correct.
And is it right that the House of Expertise has a great deal of oversight when dealing with design, installation and certification of buildings?
Yes, as opposed to the system in the United States where what you have is a rigorous process of certification, here what you have is a group of individuals that are anointed as experts, and those individuals have the power of adjudication, and therefore the actual quality of the product depends on the quality of the House of Expertise.
Yes, I see. And every building has to go through that House of Expertise checking process, is that right?
Yes, it's a choice of the House of Expertise if they want to look at the building or not.
I see. So they're probably only going to look at the most complex buildings, is that right?
The ones that they deem that requires their attention.
Yes, I see. And is it right that this House of Expertise is a group of fire and life safety consultant companies that advise the Dubai Civil Defence Authority? Is that right?
That is correct.
And is it your understanding that they are selected by the Dubai Civil Defence Authority?
That is correct.
And is there any published criteria for their selection?
Not that I know.
Is there any list of required competencies for their appointment?
Not that I know.
So would you say there's a lack of transparency about who those experts are and what criteria they've been appointed?
Yeah, I think using the word transparency is probably not appropriate. I think it is more the fact that it is not clear what expertise do you need to be able to appoint an expert, and therefore it really depends on the individuals. So the onus is entirely on the individuals.
Yes, I see. Now, if we could look at page 213 of your report, JTOR 706, page 213. And I want to look at what you say at paragraph A3.12 at the top there. This is where you're dealing with the UAE system. You say, like in many other countries, enforcement and inspection of facade systems has been strengthened, and changes to the regulatory framework have aligned the UAE to existing international regulations, particularly Europe, the UK and the USA. Nevertheless, the changes are in general minor, and what is different in the approach taken by the UAE, as described above, is the full confidence in the Civil Defence Authority as the competent authority in charge of making all critical decisions. So that reinforces the point you've just made. You've put the onus on determining the acceptability of external walls on this single body who's advising the Civil Defence Authority.
Exactly, that's correct.
Now, is that a model that you consider to be adequate and robust, just standing back and looking at it objectively?
Well, I mean, I think that it's a very limited model in the sense that you really require a very significant scrutiny of those individuals, because what you get afterwards is the whole chain. So if you make a mistake on who you're going to appoint in place of this group of people, then you will propagate that mistake undetected, all the way to the end. So while it could work if you get the right people in place and you have mechanisms to get the right people in place, there is no redundancies or robustness to the system.
Yes, I see. Now, Dubai Civil Defence have also provided information about another change that occurred in its 2018 code. If we can go back to their submission, this is DCD 701 at page 3. And I want to look at paragraph 6.6. It's the penultimate paragraph on that page at the bottom. It says here, the UAE's diversity and mixed population demographic is also understood to have been one of the main reasons for the decision to adopt the policy of confirming a fire and evacuating a building rather than the stay-put policy widely implemented elsewhere. So in other words, is this right that in the 2018 Dubai Code, which was really the first code that actually grappled with external wall performance, they've abandoned any reliance on a stay-put fire safety strategy. Is that correct?
Yes, that is correct. They would have favored an evacuation strategy as opposed to stay put earlier on, but it was not enforceable, as I say, until 2018. And in many ways, I think when you read this type of submissions, you need to understand that the places that they're describing as elsewhere generally are a function of the fact that in the region, either you're very influenced by North America or you're very influenced by Britain. So you will have a number of the Emirates and other places where you will have the same policies as in the UK. In other words, stay put will be considered seriously, and you will have other places where they will follow the North American approach. And so we need to look at this quite carefully in that context.
Yes, I was going to ask you about that. So in that last sentence, when they say rather than the stay-put policy widely implemented elsewhere, I think what you're saying is you don't read that as saying stay-put policy is widely implemented elsewhere globally, but widely implemented elsewhere in that particular region.
Yes, and in particular in places that they will follow the British model as the approach to fire safety.
Yes, so I think you're saying that there are pockets within the UAE that have just simply followed our regulatory system. Is that correct?
Yes.
Yeah. But they've now abandoned the stay-put policy and instead they are mandating an evacuation strategy. Is that correct?
Yes, which is much more aligned with NFPA. So Dubai is moved slowly, towards a North American approach.
Yes. And is that primarily a phased evacuation strategy, or does it differ building to building? Could you get some buildings where it's a full evacuation from the get-go?
Well, it depends on how the building is classified, but yes, most high-rises will have a phased evacuation strategy.
Yeah. And just to be absolutely clear, how will that work? I mean, in a high-rise building, typically how many floors are you evacuating in a phased way?
Yeah, so the typical approach to it is that, particularly in a residential building, in that context, that normally if you will not consider the alarm in the unit, because the reality is that will lead to many false alarms, and so we do not want to consider alarm in the unit. But the moment that either the fire is verified in some cases, or that you will have a detection system in the lobby. So the moment that one lobby is compromised, that will immediately start a sequence of evacuation. Now, in some countries, you will have the floor of the fire will evacuate, and the floor above, the floor below. In some countries, it will be the floor of the fire, 2 floors above, 1 below, and then it cascades. So every 2 minutes, you get 2 more coming in, or 3 more, depending on the rules. But basically, that will be the process. So you will have an alarm system that allows you to minimize nuisance alarms, but at the same time allows you to provide warning to people so that they can start the process of evacuation, and then you will do it at a staged way by taking a number of floors at a time.
Yeah. And thinking about the position currently, globally, how common would you say that phased evacuation approach is?
I would say if you take high-rise buildings in general, I would say most countries will have a provision for stage evacuation for high-rise buildings. In countries like the UK, that provision will exist for office buildings, but not for residential. But I think to a great majority, you will have a provision for stage evacuation also in residential buildings around the world.
Yes. So to what extent is this jurisdiction an outlier at the moment in retaining a stay-put strategy?
I think the UK is an outlier in the sense of its rigidity. So there is no alternative. In that sense, it is truly an outlier. And even in countries where they have retained a significant number of situations in which stay put is acceptable, they will still have a provision that in case it's not, you can move into a plan B.
Yes. So do you mean that they would, for example, have the technology within the building to have a communal alarm that can switch to a phased evacuation strategy if that becomes necessary?
Yeah, it could be a technological solution, or it could be provisions in regards to the training of the fire brigades that will be trained under certain circumstances, to initiate an evacuation process. I mean, obviously, the inclusion of some level of technology is always incredibly helpful, because even if it's going to be driven by the fire service, it enables communication with occupiers in a very effective way. So yeah, I mean, I think where I would say the UK is truly an outlier is in the absence of alternative provisions.
Yes. And it sounds from what you're saying, and it would follow from the number of jurisdictions that have had a phased approach as its primary approach for some time, that the technology is there and is readily available to enable that. Is that correct?
Yes, I think that you will find in many sectors that people will argue a number of reasons why we should not have a provision for egress. And but at the end, all those reasons in many ways fall apart. I mean, people will argue, for example, that if you have too many alarms, people become numb and they will not pay any attention. So you hear those arguments very commonly here in the UK. But you have means by which you can, as I explained, if you actually put the alarm in the lobby, that will immediately reduce the nuisance alarms to a very, very low level. If you give the fire service the prerogative of being able to start this process, not by having detection, but by actually just having a mechanism, a technological mechanism of communication, again, you're eliminating all these excuses. And I think this is a matter that really deserves a very rigorous analysis, because I still haven't found any reason why a stay-put strategy is beneficial or necessary. There is no technical reason for that. And even the argument that there is a danger by detonating a full evacuation of a building, I don't believe that there is enough information that points in that direction when 90% of the world does it on a regular basis, and we don't see that danger manifest itself at all. So I think this is a matter that really requires a very thorough analysis, because I have not crossed a real solid argument that enables me to say that this is a very, very good reason why stay put should remain.
Yes. And I mean, I think you told us about Dubai, that in practice they'd been preferring a phased evacuation approach anyway, but they couldn't mandate it. But subject to that, has there been any, or have you received any feedback about how it's gone there, going from a stay-put strategy to a phased evacuation formally?
Well, I mean, I think, as I say, it's something that has happened in a natural way, and it has also happened as a function of the growth of the city. So it's very difficult to assess, whether that transformation has been effective or ineffective, in the sense that as buildings became taller, more complex, and increased massively in number in Dubai, mostly because the developers or the owners or the occupiers of the building wanted to have a higher standard than what Dubai required. They were generally trying to follow either, most generally the North American approach. So in many ways, people will benchmark the solution against the NFPA solution. And so it has been a natural progression that has happened with the evolution of the country.
Right. And in your report, and we'll come back to it later, you've said that measuring the rate of vertical flame spread is a much easier thing to do if what you're then looking to is a phased evacuation strategy. Have they changed their testing system in any way which enables them to measure that rate and therefore support that strategy?
No, I think that the legislation in Dubai, as I say, is very much piecemeal and is mostly predicated on copying an approach that has been followed by others. So in principle, there has been no innovative approach towards improving their testing practices. They have retained NFPA 285 or BS 8414. In both cases, there is no real tangible assessment of the rate of spread and its evolution in time. So that information is missing. But again, comparing it back to the North American model, if you implement so many redundancies and you put so much fat into the system, the tendency is that the system has, at the end, a better performance. And if you, on top of that, reduce the uncertainty in the implementation of the solution by making sure that there's only one path to the solution by having a rigid prescriptive approach, you find yourself in a situation that in some of these major fires in Dubai, you had extraordinarily fast rates of spread, as you saw from my phase 1 report. Nevertheless, people had the capacity to move straight into a stair that was protected by multiple levels of redundancy, and they did that so fast that they didn't enter into conflict with the fire service and so forth. So in many ways, it is almost, I would say, not a purposely built solution to the problem, but one that just simply works because you throw a lot of things to it.
Yes. So would you say that the 2018 code in Dubai effectively is trying to mirror what we see in the US?
Yes.
In terms of the number of extra safety provisions. So
Yes.
does that mean 2 staircases?
Yes.
Sprinklers?
Yes.
Yes. So all of that is mandated?
Exactly.
I see, yes.
And even to the point that many times what you will get is in the contractual provisions, it will say you have to design according to NFPA.
Yes.
That's what you will get in many buildings in the Emirates.
And have they allowed for an alternative approach outside of that prescriptive system?
Well, I mean, as I say, many times that sort of prescriptive mimicking of the North American approach is a contractual agreement that is driven by the needs of the developer, and but because otherwise the alternative is to follow the very skeletal building code that Dubai has that is extremely basic. And as you saw with the 10 points, I mean, that's the level at which the local code is developed. Nevertheless, the regular practice is to immediately mirror, what North America does, and as I say, in many cases also what Britain does.
Yes, I understand. Thank you. Now, in your report, you identify the outlier to the general trend that we've seen internationally as Australia. And I want to spend a bit more time on Australia. Now, like the United States, Australia is a federal government system comprised of states and territories, isn't it?
Yes.
And it's right, isn't it, that there is some overarching legislation, such as the National Construction Code, is that right, the NCC?
Yes, that's correct.
But is it right that then each of the states and territories has its own legislation for building development, approval, inspection and certification?
Yes, and also professional registration.
Yes. And is it right that each of the states has adopted different ways of dealing with the fire safety and building construction in terms of those elements?
Yes.
And you mentioned several important studies of the construction industry that were carried out in Australia. You mentioned the Lambert report commissioned by the New South Wales government published in October 2015. You mentioned the Shergold and Weir report commissioned shortly after the Grenfell Tower fire and published in February 2018. And you also mentioned the Warren Centre reports, which had been planned from 2012, but were officially launched in July 2018. And some of the studies from the Warren Centre were published in January 2019 and some in January 2020. So those are the different reports you've referred to generically in terms of studies in Australia. And I just want to go to what you say at page 213 of your report, JTOR 706, page 213. So if we look at the first paragraph under the Australian response, so A3.14, you say this. You say the La Crosse building fire that occurred in Melbourne on the 25th of November 2014 was the first external facade fire of significant magnitude to occur in Australia. This fire came together with several other failures that encouraged the Australian state and federal governments to undergo a series of studies on the state of the construction industry. The three main studies are the Lambert report, the Shergold and Weir report, and the Warren Centre reports. The Warren Centre reports were a collaboration between the Australian state governments and the fire safety engineering industry at large. While the Lambert report was commissioned before the Grenfell fire, the Shergold and Weir report was commissioned in August 17, immediately after. And then you say the Warren Centre reports have been in planning, although it was since 2012, although it was the impetus given by the Grenfell Tower fire tragedy that allowed the study to materialise. And then in the next paragraph, A315, you say, whilst focusing on the Australian construction industry, these three reports present a deep introspection into professional practice in the construction sector that is applicable globally. These three reports have already had a profound impact in Australian construction and are worthy of detailed scrutiny. So does this tell us that in Australia, they've been considering fire safety design in a pretty deep way for some time, and even before the Grenfell Tower fire?
Yes, Australia has a number of particularities. I mean, the first one is that, in a way, is the birthplace of functional requirements for fire safety. There was an earlier Warren Centre report that migrated Australia into the introduction of functional requirements. And therefore, as a result of that, they have a fairly long history of applying, in one way or another one, functional requirements. They still have a prescriptive alternative, and a very significant part of the design still remains prescriptive. But they've had a long tradition of trying to apply functional requirements to the design of the buildings. So as a function of that, obviously there has been a significant amount of effort in trying to understand the benefit of the introduction of those functional requirements. But in parallel, there's been a recognition that the quality of engineering started deteriorating. And as a result, there were a number of failures that were observed in numerous areas, not only fire safety. There were structural failures, moisture ingress failures, all sorts of failures that had the Australian market very much sensitized, to this idea that something is not working. Now, then there was the La Crosse building fire, and the La Crosse building fire was a very strong wake-up call. And there were no casualties in the La Crosse fire. Nevertheless, the fire propagated all the way to the top of the building, and it was in a sector of the Docklands in Melbourne that was considered to be representative of the sort of higher quality construction in Australia, and therefore that detonated a much deeper introspection. Now, nothing had really been achieved after the La Crosse fire other than the fact that there was a lot of discussion around professional circles that there was something wrong. And it was when Grenfell happened that that fire entered the picture with the other forms of failures, as being essential in the analysis of the state of the industry.
Yes. So would you agree with this, that Australia are ahead of the curve and ahead of us in terms of appreciating that if you're going to have functional performance requirements as your base system, what you need underpinning that is an awful lot of other pillars which are going to support that functional-based approach?
Yes, there was a recognition of that. Now, clearly, before Grenfell, while there was a recognition that there were elements that were missing, it was not fully clear what those elements were and how you actually put them in place.
I see. Yes, that's helpful. And I just want to ask you about the Warren Centre reports in a little more detail. So these sit across all the Australian states and territories, don't they? They're not a state. It's not a state-specific thing, the Warren Centre reports.
No. So the Warren Centre is part of the University of Sydney, so the work was started in New South Wales, but it was, for example, partially funded by the Victorian government, and it was led by somebody from Queensland, so it was pretty much a federal effort.
Yes, thank you. And if we look at page 193 of your report, paragraph A228, you say this, you say the issue of competency and its role in the adequate implementation of fire safety in the built environment is comprehensively addressed by the Warren Centre project. The Warren Centre project focuses on the Australian context and was conceived before the La Crosse building and Grenfell Tower fires, but finally emerged as a response to these events. And this project delivered the following 9 reports. So we've got the first report, Regulation, Control and Accreditation report, second, education report, third, methods report, fourth, roles report, fifth, competencies report, sixth, professional development report, seventh, accreditation and regulatory reform report, eighth, final report, and ninth, comparison of the fire safety engineering FSE guidance documents and assessment criteria report. So it was released in a number of separate reports.
Yes.
And then you say this below that, you say at A229, you say the Warren Centre reports analyse the relationships between regulation, competency and adequacy in the context of fire safety engineering design, and finishes by delivering a pragmatic plan on a transition from the current state of fire safety engineering and design for Australia. It is my strong opinion that these documents are directly applicable to the reality of the situation in the UK, and the process followed for their development is a very good example of coherent government, industry and academic collaboration towards the delivery of a common and pragmatic plan of improvement. Now, you say it's your strong opinion. It feels like in that section of your report, you're really urging this inquiry to look very closely at those Warren Centre reports. Is that fair?
Yes, that's really fair. I think that if I can allow myself to give you an example, at some point, Mr. Millett gave a question to Professor Bisby in regards to what is the necessary level of competency, and it was very difficult, for Professor Bisby to be able to answer that question correctly, and he answered it more from the perspective of what do we need to guarantee as a framework to make sure that the people are competent, as opposed to what is the level of competency that is necessary. I think that was the recognition that occurred in Australia, that after this many years of practice with functional requirements, that any simplistic approach towards competency was inappropriate. You cannot define competency by answering that question, or you cannot define the necessary competency by sitting in a committee and in 2 weeks come up with a definition of competency. Fire safety engineering is an incredibly complex discipline that is massively multidisciplinary, and therefore the definition of who a fire safety engineer is an incredibly complex process. But it's not only that, it is not only the definition of who a fire safety engineer is, but basically what is the competency that all the other disciplines that work with the fire engineer have to acquire to be able to have an appropriate relationship between the fire safety engineer and the architect, or the fire safety engineer and the structural engineer. So how much does a structural engineer need to know to avoid dismissing the competency of a fire engineer? There's a relationship of power that also has to be taken into account. There's so many layers to the definition of competency that it was really required to develop these 9 reports to make clear what are the next steps. And that was, as you pointed the dates, it was almost 2 years of work of a very large number of people to try to establish all these relationships, how they pertain accreditation, how they compare to other international standards. You have to look from many, many, many angles, and you have to start asking yourself questions like, for example, what is the difference of a fire protection engineer that operates in a North American prescriptive environment with a fire safety engineer that actually works in an environment where functional requirements are the expectation? So these are 2 completely different professionals with 2 completely different set of knowledge that actually have to be certified in completely different ways. And none of these questions are questions that can be easily answered. So I think it would be foolish, to ignore that body of work, because while it is not fully translatable to the British system, clearly there is an enormous amount of background work that can help understand the intricacies and complexities of competency.
Yes, thank you. Mr. Chairman, I'm mid-topic, but I think this is as good a moment as any for our afternoon break. Yes.
Yes, all right. Well, then we'll take our break for the afternoon there, Professor Torero. We'll stop now. We'll come back at 20 to 4, please, and then we'll carry on.
Thank you.
Yes, thank you very much. Perhaps I ought to remind you that I said this to you on many previous occasions. Please don't discuss your evidence once we're out of the room.
I won't. Thank you.
Thank you very much. Thank you. 20 to 4, Ms.
Thank you.
Would you ask Professor Torero to come back in, please? Right, Professor, ready to carry on?
Yes.
Thank you very much. Yes, Ms. Crick.
Yes, thank you. When we broke off, we were discussing the Warren Centre reports in Australia. Now, just a quick question. These reports are publicly available on the University of Sydney's website, aren't they?
Yes.
And if we can go to the final report, that's at INQ 14934. This is their final report, report 8 of the series. And if we go within it to page 8, what we see is a summary of the previous reports and the recommendations in the series. And it's a huge body of work, so we can't deal with every element of it, but I just want to highlight some of the parts of it. So if we look on the right-hand page, but in the left column, we can see there's a heading at the bottom, Education Report, Report 2. And this says, the research on fire safety engineers' education provision and accreditation by professional bodies such as by the IFE across Australia showed some very substantial limitations. Of the 3 traditional university courses teaching fire safety engineering, only one course at the University of Queensland is currently accredited by the Engineers Australia. The appropriate education of fire safety engineers requires a well-defined and modernised curriculum based on a pedagogy that will generate fire safety engineers with the competencies and attributes required for future practice. And they say currently such pedagogy or a modern curriculum has not been fully developed for Australia or internationally. Is that correct?
Yes, that's
so they
correct.
identified that kind of modern curriculum for a fire safety engineer wasn't just not available in Australia, but in fact wasn't available internationally. Is that correct?
That's correct.
And that would include at the University of Edinburgh or any of those institutions?
Yes, I think what you will find is University of Queensland, University of Edinburgh, and the International Masters in Fire Safety Engineering are probably as close as it gets, and to try to develop professionals that can operate within a functional requirements framework. And nevertheless, there's a number of reasons why those programs have not been able to evolve to fully what the Warren Centre report recommends as the appropriate pedagogy and the appropriate curriculum.
And in headline points, what are those key reasons why they haven't been able to evolve to fulfil their full potential?
I think in general is mostly associated to the lack of recognition for the need. And I think what you find in all these programs is they're all very small and they're all struggling to try to keep up a reasonable, I would say, number of students so that they become viable. And I think in essence, it represents the conflict between organizations that are aiming at delivering the appropriate level of education and a practice that doesn't consider that necessary. And because that's the case, and you don't really need this education to be able to practice, then obviously that results in a very limited market, for these individuals. Now, obviously, people that are graduating from University of Edinburgh, for example, they will be immediately taken by the practice because people recognize that they're at the higher level of competency. Nevertheless, they can still fill their ranks with people from multiple other backgrounds without necessarily recognizing the value of this particular level of knowledge.
Yes, I understand. And is that one of the reasons, one of the things we see in the Warren Centre reports is an emphasis on promoting fire safety engineer as an attractive career path, actually trying to make it more attractive for candidates? Is that one of the learning points that came out of that work? Yes,
I think that fire safety engineering tends to be seen very much as a specialty, and therefore it is difficult, to recruit 17-year-olds into this type of programs, and people at that age tend to prefer broader disciplines. And but even in these broader disciplines like civil engineering or architecture or mechanical engineering, there is no provision for providing some level of competency in that space, so that, for example, an architect can discharge their duties as an architect correctly, because they will have to know some level of fire safety. So I think it is a combination of both. I think, and yes, of course, the Warren Center emphasizes that as one of the reasons. But I think also if these professionals were very heavily demanded by the construction industry, then that will be a true motivation for people to enter these degrees.
Yes, thank you. And just, I want to carry on just reading from that column where I picked up. There's a sentence beginning just before the halfway point on that right-hand column that begins current curricula. It says, current curricula focus on the knowledge base that underpins the profession and ignore many other professional attributes. Current curricula have undergone very little development over the past 25 years. The accreditation of degrees as satisfying the requirements for first stage of the accreditation process, or the review of competencies through an alternative route to registration by the IFE or EA, can hardly be consistent or robust given these shortcomings. And then it goes on. The key recommendation from this report was a call for development of new and improved best practice competencies, which could then be matched by updated university education courses for fire safety engineering. So you see that there. And then if we go on to page 9 on the following page, on the left-hand side, there's a heading Roles Report for Report 4. And this said, this report has developed new roles for design fire safety engineers, those undertaking peer reviews, and those fire safety engineers working in the fire authorities. The proposed roles reflect the recommendations of the Shergold-Weir Building Confidence Report and the Hackett Report. The report calls for design fire safety engineers to be involved from concept design through to handover, involvement in construction, inspections, and commissioning. And it says the report obviates the need for projects to develop a holistic fire safety strategy, a complete package of fire safety measures, and a suitable manual for use by building managers and occupants. Now, just pausing there, that last sentence, the report also obviates the need for projects to develop a holistic fire safety strategy, a complete package of fire safety measures, and a suitable manual for use by building managers and occupants. Can you explain what that means? Why does the report obviate that?
Well, I mean, I think that if you want to take advantage of a functional requirement framework, the first step is that the fire safety engineer becomes truly a designer. So it's an individual who has to juggle a number of different options, and will have many of the attributes of the designer. So, architects, for example, are very well versed in this type of concepts, and they have specific pedagogies that enable them to develop those attributes. Obviously, there's going to be skills that pertain to the discipline itself that, of course, are also going to be part of the curriculum. But at the end, what you're looking for, and this is, I guess, the philosophy behind this statement, is that you are aiming at developing a holistic fire safety strategy and providing the complete package of information that comes with it. And that complete package of information that comes with it is going to also be directed towards other professionals or the building owners or occupants, that they have to have the appropriate level of information that enables them either to discharge their own duties, but also to be able to safely occupy this building. So in many ways, what the report sees this as a self-evident truth, that all these things need to be in there if you really want to deliver an appropriate fire safety strategy within the context of a functional requirements framework.
Right, I see. Thank you. And then we've got, still on this page, but on the right-hand side, there's the competencies report, report 5. If we just go to the right-hand side of this page. So, and there it says, the development of competencies for fire safety engineers has been informed by the roles report and the future roles of fire safety engineers as proposed in this research. The competencies have examined the knowledge, skills and personal professional attributes needed by a fire safety engineer in the future. They've been based on the competency framework of the International Engineering Alliance, the Washington Accord requirements and the general framework utilised by Engineers Australia. The proposals address competencies to be gained through Stage 1, academic training, and Stage 2, supervised professional experience, milestones, and the report lists indicators of attainment to assist in competency assessments for accreditation by professional bodies such as the EA and the IFE. So, is this right? In summary, it's addressing competency at all stages of the process, both at academic stage, but then also as a practitioner, what the competencies are that you would need.
Yes, engineering practice or design practice is not only about the education that you receive. You know, it is about being able to demonstrate that you can exercise the practice appropriately. And this is what the supervised practice stage introduces in the certification process of a professional. So you enter the discipline demonstrating that you have acquired all the necessary skills and attributes. Then you have to demonstrate that you can practice. And that's where you're supervised, and you normally will assign a period of 2 to 3 years or something like that. And then eventually, that's what brings you to full certification, where you can actually operate as a professional independently.
Yes, I see. So it's very much a staged process of getting someone to be the finished article.
Yes.
Yes. And then in terms of professional development, on the right-hand side, we can see that Report 6 says this report examines the research findings and recommendations on professional development of fire safety engineers from all the earlier research and reports. It assembles a comprehensive set of recommendations with supporting evidence in relation to competencies, education and career pathways, as well as professional development more broadly. The recommendations on education for fire safety engineers specifically address the competencies and attributes required for professional practice to create a level of professionalism which will be attractive to and encourage greater numbers of engineers to consider a career in fire safety engineering. Now, let's also go to the executive summary on page 4. So here, what we have is some key recommendations. In fact, it begins there, and if we go to page 5, what we see is a series of bullet point recommendations on the left-hand side of the page. And I just want to highlight or go through a few of those with you. So if we look at the left-hand column of the left-hand page, perhaps if we could blow that up. It says, in order to create a full and proper profession of fire safety engineering and meet all of the recommendations of the Shergold-Weir Building Confidence Report, this final report of the Warren Centre project recommends fire safety engineers need to be given the professional responsibility and accountability for their overall design and implementation of the fire safety strategy. So, Professor Bisby earlier was talking about you've got to know who's making the decisions. And does this framework, or the recommendations in this framework, allow more certainty in terms of who's taken responsibility for certain fire safety design decisions?
Absolutely, that is the purpose of that bullet point. Something that people do not recognize is that when currently, for example, in the United Kingdom, when a fire safety engineer enters the design process, 90% of the decisions would have already been made for them. And even then, when they come in and they start interacting, there's other participants in the design process that will still take or impose decisions on them, which on the one hand takes away the responsibility of the design and takes away the responsibility of the outcome, but on the other hand also gives the fire safety engineer an excuse to hide behind these decisions that are being made by others in such a way that they actually relinquish that responsibility entirely. So it creates both problems. So the fire safety engineer has to be responsible for the fire safety strategy and the demonstration of the outcomes of the fire safety strategy. And only when you give the fire safety engineer that full responsibility, they will take an appropriate seat at the table with the rest of the designers.
Yes, and that's introduced via legislation. That's the recommendation, isn't it?
Yes.
Yeah. And then in the fourth bullet point, it's at the bottom of that left-hand column. It begins in being. It says, in being responsible and accountable, fire safety engineers should be engaged from concept design to practical completion and handover. And as such, they should be responsible for the building fire safety design process and specification of the fire safety strategy, pre-construction, and, if we go down, verification that the fire safety design meets that's the National Construction Code performance requirements at the building approval permit stage, and that the fire safety design as constructed and commissioned as part of the project, the practical completion, issuance of the occupancy certificate and owner-manager handover is as intended. And then it goes on at the bottom, the fifth bullet point, the overall process of regulatory control of building approvals should recognise that there are other design participants who are active and who contribute to the overall fire safety of a building, including practitioners who undertake detailed design, installation and maintenance of sprinkler systems, fire alarms, fire hydrants and other fire safety measures. However, fire safety engineers should have complete oversight over all aspects of fire safety and how all the fire safety measures interact with one another as part of the fire safety strategy. So it's encouraging not to have a kind of compartmentation of individuals or companies that are having responsibility for their bit of fire safety, but that you have a fire safety engineer that is responsible for the whole package, yes?
Yes, that's exactly what it is encouraged. And I think this is something that generally tends to be a very controversial statement, because the argument will be that many other professions will request the same type of control and being involved from the beginning, the conceptual design, all the way to the handover. Now, I think one of the key things that those who make those statements do not recognize is to what extent fire safety is ubiquitous in every component of building design. From the decisions on the structural behavior, layout, facade systems, services. Fire safety engineering is fundamentally everywhere, and it only parallels the involvement of the architect. No other discipline has such a broad range of influence in the ultimate design of a building. And therefore, the fire safety engineer is an individual who should actually have a seat at the table from day one, so that all the provisions are carried in the most appropriate way, and making sure, again, because of his own expertise and the fact that this is a complex discipline that requires a set of skills that is very unique, because of that, they also have to have a responsibility to verify and the conformity of all these systems that are being put in place.
Yes, thank you. And then if we look at the last two bullet points in this column, looking down at the bottom of that column, we can see the last two bullets. So that the penultimate one states the state and territory licensing registration schemes should require fire safety engineers to meet the assessment body professional accreditation requirements, have the necessary professional indemnity insurance, and be subject to practice reviews and penalties for inadequate practice of these schemes. Now, pausing there, So that's very different to the system we have here currently in the UK, isn't it?
Yes.
I mean, we have nothing like that in terms of professional body accreditation requirements, subject to practice reviews and penalties for inadequate practice of the schemes.
Yeah, I mean, that is something that currently doesn't exist in the UK within the context of engineering practice. Nevertheless, in other professional areas, there will be no doubt that these are the prerequisites for professional practice.
Yes. And then at the bottom of that page, it says, last bullet, state and territory licensing should protect the name fire safety engineer and ensure fire safety engineering services are only undertaken by licensed fire safety engineers. And I think you've confirmed that the US have had that approach for a long time. What about, for example, the UAE? Are they licensing now in the UAE?
No, there's very few places in the world where that is the case. The U.S. is probably the most prominent of all examples, and but nevertheless, professional monopoly is again one of the fundamental columns of professional practice, and so again, within the context of fire safety engineering, that might sound as a very strange proposition. But within the context of professional practice in many other areas, that would just simply be a given that professional monopoly is expected. Only a doctor can practice as a doctor, and only a lawyer can practice as a lawyer.
Yes. And then on the right-hand side of page 5, if I could look at that page and go to the top. So it states there in the left-hand column, these recommendations for professional practice of fire safety engineers can only be implemented if underpinned by another series of recommendations relating to competency, education, and professional body accreditation, including a clear and adequate definition of competency should be adopted that's a consensus agreement by the profession and the governments. A robust pedagogy for university education of fire safety engineers should be adopted. New university courses is the next bullet point, should be developed and accredited. Next column at the top, clear processes for the assessment and accreditation of university courses. A framework for the development of career pathways, and the profession of fire safety engineering should be promoted as an attractive career. So those are the other key recommendations. So it really is a very holistic approach that's being recommended, isn't it?
Yes.
So it's not relying on any one sector to ensure the competency. It's raising the competency levels of everybody from start to finish.
Yes, it's a full recognition of fire safety engineering as a profession.
Yeah.
That's what this report advocates.
Yeah. And if we can look on page 15, there's an important warning here on page 15. Under the heading General, on the right-hand side of the page, it says there, it's essential to emphasise that the list of recommendations does not represent a set of optional actions from which government, professional bodies and educational institutions can pick and choose. The success of the overall framework depends on a concerted advancement in all aspects. Neglect of any of these recommendations can render the integrity of the process flawed. So I think that what that's saying is where you've got a functional performance system as your basic system, you don't just need some of these pillars to uphold that. You need all of those pillars, and all of those need to be in good order before you can guarantee that you've got a system that's delivering the right levels of fire safety. Is that what you're saying?
Yes, absolutely.
Sorry, not what you're saying. What this report is saying.
Yeah, no, I mean, it's that is a really interesting point, because it stems from a realization. This is not just an abstract concept. When Australia implemented functional requirements, they made an attempt to put everything in place, and it was a similar Warren Center report at the time. Now, if you look at the original Warren Center report and you look at all the things that they implemented, the one aspect that they failed to implement appropriately was all aspects associated to competency and the recognition of competency. And so 30 or 40 years later, they recognize that a lot of the flaws of the application of these functional requirements was from the fact that they missed the opportunity of creating that final aspect of the chain, and it became the weakest link. And therefore, this recommendation is a very important one, because it basically tells you that you really have to cover all the bases if you want to have an appropriate functional requirement system.
Yes, thank you. And you'll have the opportunity in due course to to propose recommendations that you think the chairman and the panel should be considering. And I don't want to stray too much more into that at this stage, but is it your opinion that this work is directly relevant to the UK's position now in terms of where it's at and where it might go?
Yeah, absolutely, because if you read this work, I would say, well, as I say, there is an application towards the Australian reality. It is based on exhaustive work that covers an international basis. So it is not only looking at the Australian regulatory system, it's looking at the British, at the American, it's comparing the different types of professionals, the different types of practices. So in a way, it's almost all the groundwork that needs to be read before you start thinking, how you implement a competency framework for the UK. And this is why I believe this report is very important.
Yes. And within the fire safety community, how were these series of reports received? Were they received positively? Have they had have they had critics?
Well, I mean, I think there is. That's a very, very complicated question to answer, because I think that there are certain sectors of the fire safety engineering community that very rapidly identified that this is a difficult path, but it's a path that we need to follow. And therefore, the effort that is necessary to be able to deliver a correct competency framework is something that needs to start now. And so you will have a group of people who are very, very proactive at engaging with this type of recommendations and trying to make sure that people hear this type of comments. Now, obviously, there's another very significant sector of the professional practice, if you want to call it that way, that obviously feels that this is a serious challenge to their position in the practice. If you were to implement this type of a framework, it is very likely that a very large fraction of the current practice will be displaced. And as such, that becomes a very difficult proposition. Now, obviously, the report has a whole section where it describes the need to provide the opportunity for upgrade, so the need to create the professional, continuing professional development, all the mechanisms to give the greatest opportunity to people so that they can lift their level and be able to practice within the context of this framework. But obviously, that can be seen as a true threat. And the best way, I think, to try to avoid that threat is through indifference. So you will have a very large sector of the practice who has fundamentally decided to ignore this work, and they have come up with a number of very ineffective substitutes to the groundwork. Because I think one of the key benefits of this report is the effort and the intellectual investment that went in developing this report. So there's a very significant sector of the practice that has pushed an alternative, and that alternative is, let's get together in a committee and within 6 weeks make a decision of our competency future. And I can guarantee you that that approach is not going to work, because that approach doesn't look into the complexity of the discipline, it doesn't look into the complexity of the relationships between this industry and all the other industries that surround them, and really doesn't look carefully enough how you actually change a mindset so that the practicing individuals are capable of embracing the functional requirements framework, as opposed to continuously trying to revert back to reinterpret everything in a prescriptive way. So there's a whole sector of this report that compares the mindset of the prescriptive engineer that will prevail, for example, in a North American model, with the mindset that you should have if you want to operate in a functional requirements framework, and looks carefully into the British hybrid, which basically is a functional requirements framework that people are interpreting as a prescriptive set of regulations. So all these things are explored in great detail in the report and related to the education that needs to be provided to those individuals who are going to enter the practice. And I think we have to be quite clear about that information is very fundamental, is embedded in higher education pedagogy, and therefore needs to be considered as carefully as possible. And so as I say, there's the two sides. There's sort of the indifference, and then there is the other side, which is the advocates.
Yeah, thank you. Now, in your report, you then look in detail at the responses of 3 particular Australian states, Queensland, New South Wales and Victoria. Now, can you explain, if these Warren Centre reports were coordinated cross-state pieces of work, why was it then that individual states developed their own responses? Was that simply due to particular local conditions within those states?
Yes, in some ways. I think the states were willing and interested in participating in the Warren Centre report. Nevertheless, the one thing that had to be recognized, there was a sense of imminence that was behind the actions that government had to take. There was a very clear identification of a very large number of buildings that had very complex cladding systems, many of them highly combustible, like in Grenfell Tower, and therefore there was an enormous pressure to take action. So Victoria and New South Wales opted very rapidly for taking the drastic action of going straight into trying to ban things in one way or another. Now, from my perspective, they approached this in an erroneous way, very similar to what has happened in the UK, that we implement a pseudo ban, which is not really a ban, but it is you're banning certain things, but allowing others that actually are not that clearly correct. So just to give you an example, the state of Victoria made the decision that they will ban all ACMs that had an infill product that contained less than 30% inert. So basically, whether it was polyethylene or any other polymer, it had to be mixed with a percentage of inert. That didn't make it non-combustible. To some extent, they set up an arbitrary threshold, and that arbitrary threshold didn't take into account the physics of the problem. So all of a sudden, you are putting a ban, but that ban is really not a ban, and therefore you can still design systems that are dangerous, that are complicated, that don't perform appropriately. Nevertheless, you've eliminated some of them, but you still are messing around with the rest. So this was done very rapidly, and it was done fundamentally under political pressure. Now, the state of Queensland took a much different approach, and the reason why they took a much different approach was because the University of Queensland had developed a very strong relationship with the fire service. They had been providing for years training to the fire service, and they had engaged in a process by which there was a very strong symbiotic relationship between the Queensland Fire Brigades and the university. And that had landed them years before Grenfell in a situation that was quite interesting. So this was a building that was entirely cladded with polyethylene-filled aluminum composite panels. And the fire service decided to put a recourse to stop this building, and worked hand in hand with the university to try to go to in Australia they have it's like a appeal panel in the construction industry. When you get into a stalemate between the authorities, you can bring your case to this appeal panel, and they will make a final decision of whether this building can proceed for approval or not. And so one of the very, very interesting things that I think sensitized the Queensland Fire Service, to this issue was the fact that they enlisted the university and they worked together in putting a case forward to stop this building, and they lost the case on completely arbitrary grounds. and they immediately internalize this and recognize, how unfair, let's put it that way, the system was. So when Grenfell happened and immediately governments decided that they had to take action, the Queensland Fire Service worked very closely with the Queensland government to try to find a better alternative. Yes. And what they proposed was the idea of developing the tools and knowledge base, or the database that will enable them to address this problem in a technical way. And that required for them to be able to not only have the tools and the database, but also to uplift the level of practice so that people will understand how to use this information correctly. So they worked hand in hand in developing a whole sequence of CPD modules that basically were enabling professionals to use the knowledge that was being developed so that they could address the problem correctly.
Yes. Now, so focusing, and you give quite a lot of attention in your report to the Queensland system, if we could bring up their submission to the inquiry, that's at QLD 702. So we've had submissions, and I'll take you to each one of them, from New South Wales, from Victoria, and from Queensland. And this is the Queensland government submission to the inquiry. We can see at the front it's by the Non-Conforming Building Products Audit Task Force. Now, just briefly, what was that task force?
So the state government put together a task force that included members from the Queensland Fire Service to address the problem. So it was their response to Grenfell. So it included people from areas in the construction industry and, as I say, the fire service. And so a number of stakeholders came into this task force that was going to advise the minister.
Yeah, and it also had representation from the Department of Housing and Public Works, yes. So from the Queensland government itself.
Yes.
Yes. And that was established almost immediately after the Grenfell Tower fire, is that correct?
Yes, almost immediately.
Yeah. If we look at page 19 of the Queensland submission, so this submission sets out in detail their response following Grenfell, and we can see there's a heading in gold there, Queensland Response Building Approval Process. And under that, we can see the heading Building Surveyors, and it tells us that building surveyors in Queensland must be licensed as building certifiers and are the decision makers for building approval compliance. They have responsibility for determining that compliance with the National Construction Code and necessary legislation has been achieved. And then in the second paragraph down, we can see, then under the title Fire Engineers at the bottom of that page, we can see it says in the second paragraph, bottom of the page, like building surveyors, fire engineers must demonstrate a base competence, maintain ongoing professional development and registration, and are legislatively obliged to comply with a code of practice. They must be involved if the building design proposal includes a fire safety related performance-based assessment. And then over the page, at the top of the page, it says, as with building surveyors, this framework enables practitioners to act as a group of self-determinative and autonomous professionals. The role and duties of engineers are outlined within the Professionals Engineers Act 2002 and overseen by the Board of Professional Engineers of Queensland. Not all Australian states have a comparable framework for industry professionals. So is it right that Queensland appear to have tried to implement a lot of the recommendations from the Warren Centre reports?
Yes, but they predated, obviously, the Warren Centre report, so they were implemented in I would say, sort of a previous generation approach. And I think while they were very strong behind the idea of professional accreditation, I think there was a bit of a confusion of how that is properly implemented. And I think this became quite evident through the response to Grenfell that there was a need to try to supplement the way in which this framework was implemented. The framework was not the problem, it was the way in which it was being implemented.
Yes, thank you. And Queensland required engineers to be registered. They're called the Registered Professional Engineer Queensland.
Yes.
Is that right? And indeed, you are one of those.
Yes.
They are certified in collaboration with the UK's Institution of Fire Engineers. Is that right? Yes,
which was in essence the problem. Because that's where the confusion got created, because what the process effectively did was it delegated to IFE the process of accreditation. But because IFE does not have that structure in the UK, the way in which they were implementing it was not the standard that you would expect from a registered professional engineer.
I see. So they were implementing competency standards set by the IFE, which weren't really adequate.
Yeah, which in essence, it is quite an interesting nuance. But I think if you look at the professional accreditation for any discipline, it always has two pathways. There is the pathway that you enter the professions through education and then demonstrating your capacity to practice, which in principle should be the majority, 99.99% people should go through that pathway. And then there is the exception route. So the exception route is, in some cases, you might have people that have self-educated, that have acquired the knowledge and the experience, and then you create a process of scrutiny that enables those unique cases to be very, very, very carefully scrutinized and brought into the profession through that alternative path. Now, the problem that the accreditation process followed by IFE has is that almost the integrity of the people that were accredited through that process came through the exceptional path. And nobody came through the appropriate or the traditional path. And therefore, the process didn't have the capacity to create the level of scrutiny that is necessary when you're allowing somebody that doesn't have the basic education to be able to enter the profession. And that has an effect of distorting completely the whole process. So you might have the correct process, but because they were applying the alternative path to the majority, then the process got distorted because you would admit many people that were not properly scrutinized, and then those people became the scrutineers. Yeah. And then the cycle, goes in that direction.
Yeah. So is it fair to say that the intention of this was valid and was as per the Warren Centre reports, but then in terms of the way it got implemented, it ended up being implemented in a way that wasn't successful?
Exactly. And I think in a way, Grenfell was the catalyzer for them to look at this carefully and recognize that they had a problem.
Yes. But just sticking with what the system, how it should have worked, just to be clear, from the Queensland submission, we can see that if registered, an engineer must undertake continuing professional development. Is that right?
Yes.
And their role is set out in legislation in the Professional Engineers Act. Is that right?
Yes.
And then there was oversight by a board of peers, i.e. other professional engineers. That's how it was designed to work. And that's very different to the other states in Australia, isn't it?
Yes, that's different to other states in Australia. But nevertheless, going back to the application itself, again, even in the continuous professional development, you see the role of the scrutineer and the role of who delivers the professional development. So if it's the practice educating the practice, so if you don't have the correct practice as a starting point, then obviously what you're going to transfer to the next generation is not going to be adequate. And I think that's the problem that had built up in Queensland. That was to some extent unique because you had the correct framework, but it was inappropriately implemented.
Yes. And then this task force set out a number of strategies. If we look at page 28, and I just want to pick up on strategy 4, which is about education programs. This is their their education strategy. And you can see the heading Continuing Professional Development of Fire Engineers. It says there, the identified need for continuing professional development, CPD, for fire engineers, culminating in the establishment of a dedicated 5-day full-time course titled External Fire Spread Risk in Tall Building Design. The course design saw the collaboration between the Queensland Government and world-leading academic institutions in fire safety research and tertiary education, the University of Queensland, the University of Maryland and the University of Edinburgh. So as part of the CPD programme, there was this 5-day full-time course, is that right?
Yes.
And that was for fire engineers. So where in the system would those fire engineers sit? Was that for the fire engineer that would be the person from inception through to practical completion, who would have had to have done this 5-day course?
Well, this was sort of the first step of what was intended to be a long process. So there was a crisis, and the crisis related to the building envelope. Nevertheless, that crisis was inscribed within a system that allowed for functional requirements, and therefore those people who were addressing the problem of the building envelope needed to really understand holistically how all that fit within the context of the fire safety strategy. And it also had to recognize that the regular practice in Queensland still was to a great extent prescriptive, and with obviously the latitude of the functional requirements, but it was in its inception very much prescriptive. And this is why you have that convergence between University of Edinburgh representing more a philosophy of functional requirements, University of Maryland representing a philosophy of prescriptive design, and everybody getting together in providing a very intense, short, concise course that will enable those who were taking the course to address the specific problem of the building envelope. It was not intended to be a fire safety engineering degree in itself. It was just intended to be a course that enabled people to address this specific problem. And therefore, the entry requirements to be able to take the course was that the person had to demonstrate that they had practiced in this space, that they had an engineering degree. So we you know, in that course, there were many attendees that were not fire safety engineers. There were civil engineers or mechanical engineers who also wanted to understand how to solve that particular problem. But it required an entry qualification so that they were capable of assimilating this information to try to address a very specific problem.
Yeah. And did you personally have some involvement in designing that course?
Yes, so I participated in at least 2 of the editions of it, and including the first one. So I was involved in the development of this course.
Yeah, and was it examined? Did the successful candidates get some kind of certification at the end of it?
Yes, so it had a very rigorous examination. And that included a practical aspect, which was they were given a particular building with a particular cladding problem, and they had to propose a fire safety strategy that enabled them, to determine whether there was a need for replacement or the building needed to add other provisions. Look at the problem in a holistic way.
And what was the rate of success in terms of people passing the course?
The rate of success was approximately 40%.
40% passed it?
Yes.
Yeah.
Despite the fact that the entry point was in principle, very high. They had to be engineers with a fairly high level of experience.
Yes. And what's the status of the course now? Does the course still exist?
No. So basically, the course run for I think 4 or 5 times, and I believe there were several other courses that were developed. There was one for building certifiers. There was another that was developed for other professionals that operated in the space, but they were not in charge of the fire safety strategy. And then eventually, the Queensland government decided, one, not to enforce the certification provided by the course, and two, they stop funding the program that enabled this to happen.
And what were the reasons for that? Why did they decide not to enforce the certification provided by the course?
Yeah, it was an interesting process because the intention originally was that this course was going to enable a group of practitioners to deliver an appropriate solution to this very specific problem. Now, as you might imagine, the fact that the success rate was not very high very rapidly created a strong opposition from the practice, who deemed themselves still capable of doing this type of work. And so it threatened the practice. And also, I think, while it did provide a direct solution to the problem in the sense that you provided a professional that could actually go out and analyze a building and give you a solution to the building, it also proved that many times those solutions were not necessarily agreeable from the side of cost and so forth. So little by little opposition started building to this. And then, of course, there was also the pressure for government to make decisions. And then eventually they opted to move completely away from this and go straight back into the policy of instating a ban on certain types of products and basically mimicking what New South Wales and Victoria were doing.
Yes, thank you. I want to ask you more about the Queensland strategy, including about testing of materials and the cladding material library, which you've touched on already, but I think we'll have to do that tomorrow. So,
I think that would be wise.
Mr. Chairman,
Yes.
That's enough for today, I think.
All right, thank you. Well, we've reached the time at which we usually stop. I think we'll return to this interesting topic tomorrow.
Thank you.
So we'll break there. We'll resume, please, at 10 o'clock tomorrow. And as before, please don't talk about your evidence to anyone while you're out of the room. All right?
Thank you.
Thank you very much. We'll see you tomorrow. Thank you very much, Ms.
Thank you.
Grange. 10
Thanks.
o'clock tomorrow, then,
Thank you.
please. Thank you.